Classes and objects are the foundation of Java programming. Everything you build in Java starts with these concepts. Understanding them well from the beginning will save you from confusion as you move to more complex topics.
Many people mix them up and think classes and objects are the same thing, but once you see it as the difference between a design plan and the actual thing built, it clicks. The class is the template, objects are the real instances.
Think of it like a house blueprint, where the blueprint shows you exactly how to build a house with all the rooms and features planned out. The blueprint is the design, but it's not an actual house you can live in.
Each house built from that blueprint is its own separate structure. Different families live in each one, maybe with slight customizations, but they all follow the same fundamental design. That's exactly how objects work. They're all created from the same class but are independent instances.
A class is a blueprint or template for creating objects, and an object is a specific instance created from that class. The class defines what fields and methods each object will have.
So in practice, this means when you write a student class, you're defining what every student object will look like. They'll all have names, IDs, and grades, but each student object holds different values for those fields. You create objects using the new keyword and constructors.
Think of a class as a cookie cutter and objects as the actual cookies. If you're coming from JavaScript, you might expect to create objects directly without a formal template, but Java requires you to define the class first. And every Java backend service starts with classes that define data models and business logic.
Class is the cookie cutter, object is the cookie. Remember that whenever you're designing your Java applications. Alright, let's move on to the next one, fields and data storage.
Since we've been working with classes and objects, let's talk about how objects actually store their data. Understanding fields is crucial because they're what give each object its unique identity. Without fields, every object would be identical.
What trips people up is confusing fields with local variables. Local variables disappear when a method ends, but fields live as long as the object exists. It's the difference between a temporary thought and a person's permanent memories.
Think of it like a person's pockets. Each person has their own pockets, and each pocket can hold different things. Your pockets contain your stuff, my pockets contain mine. We don't share pockets, and we don't reach into each other's pockets to get things.
Exactly. And just like you can't reach into someone else's pocket to grab their keys, you can't access another object's fields directly. Each object guards its own data, which is why we need methods to interact with what's stored inside.
Fields are variables declared inside a class that hold data for each object, and each object gets its own copy of those fields. They're essentially the object's personal memory slots.
So in practice, this means when you create a person object with a name field, each person object has its own separate name storage. Change one person's name, and it doesn't affect another person's name.
Unlike JavaScript where you can add properties to objects anytime, Java requires you to declare fields in the class blueprint upfront. And in real applications, these fields map directly to database columns when using JPA or Hibernate for persistence.
Remember, fields are your object's pockets. They hold what makes each object uniquely itself. Alright, let's move on to the next one, constructors and object initialization.
Before we dive into constructors, if you've been working with classes and objects, you know that creating an object is just the beginning. Constructors and object initialization are what make sure your object is actually ready to do useful work the moment it comes into existence.
Right, and this is where a lot of developers get tripped up initially. People think constructors are just another method you call when you're ready, but that's not quite right. The key insight is that constructors aren't called later, they run automatically at the moment of creation, like a setup crew that activates when a house is built.
Think of it like moving in day for a new house. It's the process that gets everything ready and set up when the house, which is your object, is first created. The lights need to be flipped on, the thermostat set, the furniture positioned, all those details that make it livable.
Exactly, and just like moving in, you don't get to pick when this happens. The moving truck shows up, the crew does their work, and then you're ready to live there. You can't decide later to have a moving in day, it's tied to that moment of creation. So in practice, this means when you write new bank account, the constructor runs immediately to set the initial balance, configure the account type, and make sure all the fields have sensible starting values.
Here's the precise rule. Constructors are special methods that run when creating a new object. Their job is to initialize or set up the object's fields, and they have the same name as the class with no return type, not even void. This is different from regular methods in every way except that they're called automatically during object instantiation.
And this matters in real Spring applications all the time. When Spring creates a controller bean with new user controller, user service, email service, it's the constructor that receives those service dependencies and assigns them to the appropriate fields. Without proper constructor initialization, you'd have null references everywhere.
The constructor pattern gives you predictable setup. You know exactly what state your object will be in after creation. And if you're coming from JavaScript, you might expect object setup to happen in the object literal or through manual property assignment. But Java's formal constructor approach ensures nothing gets missed and provides clear documentation of what each object needs to function.
That's why when you see a constructor parameter list, you immediately know what this object requires to be useful. And remember, the constructor is the moving truck that brings your stuff in. It's what transforms an empty shell into a properly furnished home. Alright, let's move on to the next one, methods and behavior.
Building on our understanding of classes and objects, methods are the behaviors that bring those objects to life. They define what your objects can do, and grasping this helps you write code that actually does something useful.
People often think methods are just functions floating around, but they're tightly bound to the class blueprint. Once you see methods as the actions objects perform with their own data, it clicks why every instance shares the same behavior.
Think of methods like recipes in a cookbook. The cookbook is your class, and there's one recipe for driving a car. But each person cooking, that is, each object you create, can follow that same recipe using their own ingredients, their own engine and wheels.
Exactly. Just like one recipe works for multiple cooks with different kitchens, one method works for multiple objects with different data. The recipe stays the same, but the outcome depends on what's in each cook's pantry.
Here's the key rule. Methods are defined once in the class but are available to every object created from it, and they operate on that specific object's fields.
So in practice, this means when you call car.start, each car object uses its own engine field to start. Your sedan's engine isn't affected by my SUV's method call.
If you're coming from JavaScript, you might expect methods to be attached directly to each object. In Java, methods live in the class blueprint and are shared by all instances, which is more memory efficient. In production, this is why Spring MVC controller methods can handle thousands of requests using the same shared logic.
Remember, methods are what your objects can do. Alright, let's move on to the next one, interfaces as contracts.
Before we dive into interfaces, let's build on what we already know about classes and methods. Classes define what objects can do, and methods are the actions they perform. Now we're adding a new layer, interfaces, that helps us define contracts for behavior across different classes.
What makes interfaces fascinating is that they're often misunderstood as a way to share code, but that's not their job at all. People get confused thinking interfaces are like abstract classes, but here's the key insight. An interface is like a restaurant menu. It lists what dishes the kitchen promises to serve, but it doesn't tell you how to cook any of them. The menu just guarantees those dishes exist.
Think of it like a restaurant menu. It lists what dishes the kitchen promises to serve, but it doesn't tell you how to cook them. The menu defines the contract. These are the available dishes, while the actual cooking, the implementation, happens in the kitchen behind the scenes.
Exactly. And just like a menu might be the same for different restaurants in the same chain, an interface can be implemented by completely different classes. One restaurant might make a burger with beef, another with veggie patties, but both promise to serve that menu item. In Java terms, both would implement the same interface but provide their own unique method implementations.
Here's the precise rule. An interface defines what methods a class must have, and classes use the implements keyword to commit to that contract. This is fundamentally different from classes and objects we've seen before. Interfaces have no constructors because they're blueprints for behavior, not data structures.
So in practice, this means when you write code that depends on an interface type, you can pass in any class that implements it. Imagine a payment processing system where you have a payment processor interface with a process payment method. You could have credit card processor, PayPal processor, and Bitcoin processor classes all implementing the same interface but with completely different internal logic. Your code just calls process payment without knowing which specific implementation it's using.
The third key fact is that interfaces have no constructors, reinforcing that they're purely about defining behavior contracts. And if you're coming from JavaScript, you might expect objects to just need the right methods through duck typing, but Java's interfaces enforce this formally at compile time. You can't accidentally pass an object that doesn't fully implement the required methods.
This matters enormously in frameworks like Spring Security, where interfaces like UserDetailService define contracts that your custom classes must fulfill. The framework knows exactly what methods it can call on your user service because the interface guarantees those methods exist. Remember, an interface is a promise list, not a cookbook. It tells you what's available, not how it's prepared.